Good afternoon, everyone. Good afternoon, everyone. Welcome to the virtual panel discussion on the future of Cuba's coral reefs. My name is Jorge Elwani. I'm the director of the Cuban Research Institute, which organized today's event. And also, I want to acknowledge the co-sponsorship by the FIU Department of Biological Sciences. This event has been organized for several months now by our colleague, Jean Rosenberg, who is also affiliated with the Department of Biological Sciences and is a CRI faculty affiliate. So we're very happy to welcome you to this event, and I'll just turn it over immediately to Jean Rosenberg, who will introduce the speakers and moderate the discussion. Welcome, everyone.
Thank you very much, Jorge. It's a real pleasure to be with you all here today. And so I'd like to also extend my welcome to you. And today's panel is on something very different for the Cuban Research Institute, on a scientific theme. The future, well, it's scientific and more broader than scientific. Even it has social dimensions, as we will see, on the future of Cuba's coral reefs. Cuba's coral reefs constitute a really precious world biological patrimony, and in fact, they represent a third of all the reefs in the Caribbean, in the insular Caribbean. And in Cuba's case, because of limited coastal development and low nutrients and sediments running off into the coastal waters, Cuba's reefs include many of the most pristine reef systems in the entire Caribbean. Now, on the other hand, other reefs in proximity to human urban centers on the island are significantly degraded, unfortunately. But Cuba's coral reefs are absolutely crucial on a regionally for dispersing larvae and fisheries production, benefiting, and this benefits the Caribbean, the whole Caribbean, and particular parts of the Caribbean and adjacent areas, including particularly Florida. Monitoring and managing such a vast area present a lot of challenges, and threats to the health of coral reefs can come from a lot of different things. They can come from climate change, including global warming and ocean acidification, from coral diseases, and also, very importantly, from human activities, such as habitat destruction, pollution, and nutrient enrichment, and overfishing. The increase of tourism and development is also going to pose threats to Cuban coral reefs. Today's panel of 4 Cuban coral reef scientists who are based in Cuba, the United States, and Mexico will examine the current status of Cuba's coral reef systems, ecological threats from climate change and human activities, as well as different strategies to manage, conserve, and restore Cuba's coral reefs for the future. Finally, and importantly, all 4 of these Cuban scientists, along with other scientists, have contributed chapters to the soon-to-be-published by Springer Verlag, soon-to-be-published comprehensive review volume titled Coral Reefs of Cuba. And this volume is edited by the eminent expert on Cuba's coral reefs, Dr. Vasil Zlatarsky, who, by the way, along with the book's editorial board, sends his greetings to today's attendees and also his gratitude to all those, including the members of today's panel, who contributed to this major work. So with that, I would like to move to our featured panelists. Just to let you know, there will be 4 panelist presentations. And I should mention that, one of the panelists is Patricia Gonzalez Diaz, has sent us a video, a narrated PowerPoint. So there will be the 4 panelist presentations, followed by time for questions and answers. So during the presentations, please feel free to use the Q&A button at the bottom of your screen and type your questions into the Q&A box during the presentation. Questions and answers period will come at the end of the panel. Please indicate if the question is for a particular panelist. And please do not use the chat function, which has been disabled for this webinar. So with that, our first speaker is our own FIU's own Dr. Alain Duran. Dr. Duran is an assistant teaching professor in the Department of Biological Sciences at Florida International University in Miami, Florida. And he's also a research associate at FIU's Institute of the Environment. And also, by the way, a faculty associate of the Cuban Research Institute. He holds a bachelor's degree from the University of Havana, Cuba, and master's and PhDs from FIU. His doctoral research was on the drivers of plant-herbivore interactions on Caribbean coral reefs and the role that they play in ecosystem resilience, the role of plant-herbivore interactions. His current research continues his focus on the ecological roles of herbivores and the dynamics and composition of seaweed assemblages on coral reefs, especially the turf-forming algae and crustose coral and red algae. And so with that, I'll turn it over to Alain.
Thank you, Jim. Let me share my screen pretty quick. So are we seeing the full screen?
Yes, we are.
All right. Thank you, Jim. Thank you, Jorge, and thank you to the Cuban Research Institute. And thanks for that welcoming of myself. A couple of things that I actually want to point out before I start talking about science and giving you guys some data. I would like to express my sincere gratitude to this institute and to the LAC, because in the past, they have funded part of the research in collaboration with Cuba. And you will see some of the data from me and also later from Dr. Gonzalez Diaz, that is research that was conducted with funding from the LAC and the Cuban Research Institute. My talk, and it's an honor to begin our discussion or our presentations for later discussion, is going to be focused on first the overall status of Cuban coral reef. Most of the data that you will see is going to be soon published in this book that Jim Rosenberg was mentioning earlier, and I'm going to close up my presentation talking about the current challenges that we as marine biologists face to conduct research and to work with the coral reef in the island. So in terms of who I am and why I'm here, I cannot talk without mentioning the role that Dr. Pedro Alcolaro and Rodolfo Claro played in my formation. Without them, I would not be here presenting today, and I feel that it would be unfair to talk to you without mentioning their names. I also would like to recognize the collaboration that I have with Dr. Gonzalez, Patricia Gonzalez, who's going to be presenting as well, and the two graduate students that we are co-mentoring in Cuba, Amanda Ramos and Patricia Vicente. They both are working there, and part of the research that you will see today is their own work. Now, it is not a secret for all of us, as Jim was mentioning, that we are facing a global crisis in terms of coral reef. Particularly in the Caribbean, there has been a reduction in coral cover and has been an increase in macroalgal abundance. They are usually related to these factors that I have on this screen, on the screen. So overfishing, eutrophication at a local scale, and more at a global and regional scale, bleaching events, coral disease, and hurricanes. Cuba is not an exception. Now, unfortunately, Cuban coral reef has been portrayed as the crown jewel of the Caribbean. And I think most of this is related because outside the scientific community, most of the advertisements of Cuban coral reef comes from Jardines de la Reina, a coral reef that is unique within the Caribbean, but it's not the only coral reef within Cuba. So by the end of my presentation, I would like you guys to think about whether or not the Cuban coral reef are all crown of the jewels, and I hope I could present enough data for you to make your own conclusions. Now, we cannot talk about Cuban coral reef status. We cannot talk about how the dynamics of coral reef in Cuba works without mentioning the diversity of coral reef in the island. And this diversity is actually related to the fact that most of the island is covered by coral reef. Coral reef that, in a simple way of classifying them, could be either shelf, reef that are bordering the shelf, or it could be crest reef or shallow reef within the back reef. Now, take a look at these numbers right here. We are talking about 3,215 kilometers of reef of shelf that is covered by coral reef, and in a total area that actually goes over 3,000 square kilometers. One thing that I would like the audience to notice is that in the north area, you find two archipelagos in which you could see the border reef, and in red here, this crest and shallow reef. And so around Havana and around the northeast of the island, the platform, the shell there is pretty narrow, whereas in the archipelagos kind of extends a little bit further out, approximately 25 kilometers. Now, look at what happened in the south. In the south, we have Jardines de la Reina, we have Archipelago Los Canarreos, that actually could be over 100 kilometers from the island. So obviously, these local factors that we were mentioning before may have a different impact on depending on where the reef are located. So I will be talking about the status of coral reef, and I want to make sure that the audience is on the same, all the audience understand a little bit about the dynamic. In this case, I'm particularly referring to the coral reef triangle. As a rule of thumb, in a nutshell, a coral reef has a given amount of herbivores. Herbivores will control macroalgae, macroalgae that compete with corals. Coral per se are the main builders of coral reef. So therefore, you would expect in a coral reef that is well protected, that's functioning well, that has high resilience, you would expect a high coral cover and a lower macroalgae cover. And that lower macroalgae cover will be mostly due to the control, the top-down control by herbivores. In the Caribbean, we do have two major groups, the herbivorous fish, which are two families, the families of parrotfish and surgeonfish, and we have another group that is not that abundant anymore, but they used to be very effective on controlling macroalgae before 1984, which are the Diadema antilatum of the long spine sea urchin. Now, what are the status? What are the numbers? How can we understand how coral reef in Cuba are currently? Again, most of the data that you are seeing here are going to be soon published and has been collected in the last 2 decades. Here you have the 9 zones in which you could separate, in which you could study the Cuban shell. And what you have in this graph here is, particularly for sea urchins, you are looking at the frequency distribution across different categories, from critical, when it is less than 0.25 individuals per square meter, to excellent, between 2.6 and to less than 7 in sea urchins per square meter. And what I want you to see, what you see this start right here, are the areas in which you can still see some sea urchins that are, I would say, healthy, because they are within the, you still have some populations that have median, so some population that have 0.5 to 1 individuals per square meter. The rest is really pretty much either 0 or has not been studied yet. But there's some hope in this sense, because if you look at the trend of sea urchins, for instance, in Jardines de la Reina, so it seems like the density of sea urchins has been increasing over time, which actually is pretty important in terms of how what could be the ecological role of this species within the archipelago. There are a couple other places in the island, one of which is Playa Baracoa. We have a student, Amanda Ramo, working with this population there now, where you can still find populations of diadema that could be as then as 15 individuals per square meter. Again, these are some specific areas along the entire Cuban archipelago where you can find diademas, and it could be possible that in other places there are high density of diademas as well. In terms of herbivorous fish, I'm presenting here the data for the density. So again, here is the scale. By the way, I should have mentioned before that this scale was created by Dr. Pedro Alcolao and myself. Back in 2011, we created this scale based on all the data that was collected with the Agra expedition since 2001. So we put all this data together and create a scale to classify, to sort of to indicate, to communicate the health of a coral reef across the entire island. So please don't take this as a specific value, and therefore this is the reef. It is actually combinations of multiple indicators. In this case, for herbivorous fish density, both group of species, the parrotfish and the sturgeon fish, you could see that in some places here, the dashed line indicates the the minimum level to be considered as a regular density. So many reef, and here are many sites, and here many regions, sorry, and here are broken by reef habitats. And pretty quick, what I would like you guys to point out, to look at here is the density, for instance, of Jardín de la Reina, which is a place considered for fish density as a regular. Now, other places are still poor. There has been some overfishing of herbivorous fish in the entire island, but for us, the most important indicator here would be, rather than density, biomass. For the audience that is not familiar with this, remember the difference between density and biomass is in biomass we actually look at the weight of the fish, which is actually estimated from the length. There's an equation to calculate that. And when you start looking at the biomass of herbivorous fish in the island, look at what happens here. So there are some places, again, Jardín de la Reina, it is in pretty good conditions. Archipelago de los Canarreos is in pretty good conditions as well. And there are others that are either in regular or poor. In many places, please notice this, and I know, I think Dr. Gonzalez Diaz is going to be talking about later of the gaps, knowledge gap that we have in the island. Now, just to put this in perspective, for the Caribbean, take a look. This is the frequency distribution. This is per fish biomass, just per fish biomass. Look at the most common biomass that you find across the Caribbean coral reef. So it is around 20, around 10. Look at these numbers right here, 60 or 40. So places in the Caribbean where you can still find that high biomass, for instance, Bonaire, but the rest is actually very low. So in terms of herbivorous fish biomass, Cuban is not that bad. In terms of the coral abundance, the average coral abundance on Cuba, and again, this is just putting all regions, all of them together in the last 2 decades, is around 20%. For those familiar with the coral reef abundance in other places in the Caribbean, it could go around 10. In Florida right now, we have around 1% to 2%. So this is kind of remarkable for the entire region. Now, obviously, there is a very high variations across habitats and across regions. Again, places such as Los Canarreos, places such as Jardín de la Reina, Guanacavives is still in a good conditions in terms of coral abundance. Again, coral abundance for today's numbers, right? Let me put this in perspective. This is another graph from Jackson's et al. Look at what happens in the entire Caribbean since 1969 until 2011. This is the trend. Either if it is a hockey stick kind of drop, or if it is a straight line drop, but there has been a drop, and right now around the Caribbean, having a 15-20% quota cover is kind of above the average, and that is what you find in Cuba. In terms of the macroalgae, the regular abundance based on the scale that Dr. Arcolaro and myself created will go in between 31% and 50%, right? And as you can see, most of the regions, and regardless of the habitat, will be within that range, except for La Habana, which you will learn a little bit more from Dr. Gonzalez Diaz, that has one of the highest abundance of macroalgae, and that is pretty much due to the lack of herbivores in the area. Now, this is, by the way, one of the first attempts to look at the relationships between coral abundance, macroalgal abundance, and herbivore biomass that has been done in the island. Back in 2013, Dr. Pedro Alcolaro and his collaborators did some similar analysis for the regions in Los Canarreos, and they found a very complex intrinsic relationship among many drivers that will drive the resilience of coral reef. But for the entire island, this is the first time that we do this kind of analysis. Again, it's going to be in that chapter for the book that Jean was mentioning before. And what I want you to notice here is that as you increase herbivore biomass, which is in the x-axis here, there is a drop, a significant drops in macroalgal abundance. You would expect that, but there's not actually much change in coral abundance, which brings more questions than really conclusions. This is currently actually being analyzed by my master student at FIU, Jackie Cruz, who is really doing an amazing job putting together data from AGRA, from many different surveys, to look at more specifically within habitat, within regions. In terms of the future of coral reef, if you ask me, one of the main problems that we have right now is there are so many gaps in what we know about Cuba, which is important not just for Cuba per se, but for the entire Caribbean. There are questions that you could think of to develop research, things that could be related, for instance, to the dynamic of coral reef at the local scale. So the other question is the potential tourist development in the island. We know that at some point, the economy have to shift. And if that happens and there is more tourism, so what is really the carrying capacity that we have in these systems? The third would be climate change and the influence, again, not just within the entire, not just including all the reef in the island, but specifically for some region. We know that Jardines de la Reina, we know that Los Canarreos are performing much better than La Habana or other places. So why? How's that going to be an indicator of the entire area, and how we can sort of allocate our management and restoration efforts? Talking about the restorations, is it a restoration, coral restoration, a viable approach? There are some attempts, and Dr. Gonzalez will be talking a little bit more about this in a little bit. The challenges here are two, in my opinion. The first one is the economic limitations. But the second one, which for me is the most concerning one, is the gap in the new generations of marine biologists. Really, funding could be obtained, but if you don't have a capacity, scientific capacity to take on those scientific tasks, that is a major limitation. And that for me is one of the most important challenges. I want to finish up my presentation, put in here a picture of these amazing collaborations. This is the AGRA project back in 2001. The second one was way smaller. This was actually the research that LAC funded in 2016, and I was able to take some of my colleagues. We went to Cuba and worked with Cuban students, and I think it was amazing for both groups. And I want to conclude by saying that really at this point, based on these limitations, based on these challenges, collaborations is the crucial aspect for not just the future of coral reef, but also the future of Caribbean coral reef. Thank you for listening up.
Okay, thank you very much, Elaine. You can stop sharing, and I'd also like to take this opportunity while I'm at it to thank you personally for the help that that you've provided in putting together, organizing this panel. I really appreciate it.
Thanks.
So also the other thing is, if all the panelists, if you could check the chat, please. Okay, there is chat among the panelists. Okay, our next speaker is, well, you've heard about some of her work, Dr. Patricia Gonzalez Diaz, and since she was unable to join us in person for today's panel, I'd like to share a photo of her, so you can see. Okay, and is that can you see that now? Can you see the photo?
We can.
You can. Okay, I'm going to make it there, and you can still see it. Oh,
yes.
All right. Okay, let's see. Okay. Dr. Gonzalez Diaz is professor in the Center for Marine Research of the University of Havana, and she actually served as the center director there for 6 years, from 2014 to 2020. And she holds bachelor's and master's and PhD, all three, from the University of Havana. Her research includes community, population, and individual level indicators of the ecological status of coral reefs, both natural and human impacts on coral reefs, and also coral reef conservation and management. She's currently there serving as the graduate program director for marine biology and aquaculture at the University of Havana, and she's also a member of the National Oceanographic Committee of Cuba. Her presentation today will be a narrated PowerPoint, and so I will stop sharing, and we can put the PowerPoint on.
First of all, I'd like to express my deep gratitude because the opportunity to share with all of you some of our results of research that we have here in Cuba in terms of the studies in our coral reefs. Secondly, for my introduction, I'd like to share with you too the general research lines that we deliver here in Cuba in the research in our coral reefs. First of all, we study the structure and function of coral reefs, the paleoclimatic reconstruction and pollution land-based on coral cores, reef health and mechanism of resilience, biodiversity patterns of corals at regional scales, as well as connectivity process and patterns. For deliver this research, basically what we do it is select ecological indicators, especially for study the processes and function of coral reefs, and as a part of these ecological indicators, we select coral diversity, density of coral sponges, gorgonian sand, diadem, and tilarum, substrate cover of coral sponges, algae, sand, and rock, coral health, and as a part of coral health, we include active diseases, bleaching, fragmentation, and other damages, as for example, bioerosion, and coral recruitment. The methodologies that we use, it is depending of the specific objective of the research. But in general terms, what we do it is use a square frame of 1 meter square, transect line of 10 meters, band transect of 10-meter long and 1 meter wide, and square frame of a 0.25 meter square for coral recruitment and also for substrate cover. Usually we work in compare the situation of impacted areas with non-impacted areas. As for example, impacted areas, we have those areas that receive land-based pollution and strong overfishing, which the best example, where the best example it is the reefs that are just in front to Havana City, which is the capital of the country. Also, we work in different MPAs that have different categories and uses, and sites with different kind of uses, as for example, tourism, diving, as well as snorkeling, both of them. In our coral reefs, the situation it is different along the country. For example, in this slide, you could see how the density of corals, the coral density, it is the lowest. We have the lowest results in front of Havana City, which I mentioned before that it is the capital of the country, and all of these reefs are very, very close to the shoreline and receive the direct contamination or pollution from the city, but also because the easy accessibility to those reefs receive also the highest overfishing. And the opposite situation, you could see how we found the highest density of corals in areas that are very far from the coast, as for example, Ancon Peninsula and Garden of the Queens. As an example of the comparison of reefs that are in the north coast, close to Havana City, and the others very far from the coast, in Garden of the Queens, one of the research lines that we deliver it is analyze the effect of benthonic organisms on restoration successful of Acropora palmata. In that case, for example, we have study areas in Playa Baracoa and Rincón de Guanao, which is in the north area, and Garden of the Queens in the south. For deliver this research, basically what we do was establish fragments of Acropora palmata close to the different organisms that were very abundant in those crests, as for example, Millepora complanata, which is fire corals, Palitoa caribaeorum, which is soft corals, Poraites astroides, which is one of the most abundant corals in our crest, and then also different kind of algae and the control. In the case, for example, of Millepora complanata, results shows that was that provoked the highest damages on the fragment of corals. However, in the case, for example, of Poraites astroides and inclusive Stipopodium algae, they no interfere in the growth and health of Acropora palmata. These results also we wrote to and inform to different agencies of our government in order to, in the case that they'd like to restore some reef crest, we don't know now where we could establish fragments or not. Other studies that we deliver are in Garden of the Queens. As I mentioned before, Garden of the Queens, it is the highest MPA in our country and one of the highest also in the Caribbean. But one important thing, it is the level of enforcement that we have there. It is unique in our country. We don't have other MPA that receive this high level of protection because enforcement. For this work, basically, we select two biotopes in reefs, the crest and terrace edge or slope. Why terrace edges or slope? Basically because we could found this biotope along all of our country. So if we like to compare the situation of Garden of the Queens with other reefs in our country, we have this biotope as a good comparison. In the case of crest, even when we don't have crest reefs along all of our country, but because the ecological benefits that provide this biotope, and also because the health that we could found there in Garden of the Queens of this biotope and Acropora palmata specifically, because of that also we select this biotope. In the map you could see different zones that we found in Garden of the Queens. These zones are regarding or according to the protection level along the gardens. In the case of 4, for example, it is in green and it is just in the middle of the park where the touristic operation is based, and because of that the enforcement level it is highest there. In the case of, for example, zone 8, 7, and 1 are in the margin of the area and receive less enforcement than in the middle. Other important point it is that in each of these zones we establish 3 sites in both biotopes. The studies that we deliver there include, in terms of benthos, include coral health. There we assess the category of coral health that we established before, as for example, the affectations, as for example, bleaching, all mortality, recent mortality, etc., and active diseases, as for example, black band, white band, spot yellow, among others. Also, we study there the health and size composition of engineering coral species, because there are the species that offer three-dimensional space and refuge in terms of rugosity of the coral reefs. For that species, we basically study the density, size composition, and health. One of the most important results that we found, it is the percentage of healthy and affected colonies. If you see in the figure, more than 70% of colonies were healthy. And basically, in all zones, the health were very, very high. In the next graph, you could see how the main affectations that what we found was bleaching and also ancient mortality. But for example, in the case of some diseases as white spots or white band or black band, we found, but in a very, very low percentage, which is a really good result. As I mentioned before, the other organism that we studied was Diadema antillarum, because the ecological effect that have this sea urchin in the coral reefs. For study this species, basically we select ecological indicators related with if they are juvenile or adults, the behavior that they have, as for example, if they appear in aggregations or solitary, the presence or not of albinism, and also the test diameter in order to understand better the size structure that have the population of Diadema antillarum. We study also the macroalgae cover in order to understand the effect of Diadema on the substrate cover. And also we establish experiment in order to evaluate the effect of herbivorism of this sea ocean. For that we establish basically one control treatment, one control and two treatments. The control was 1 meter quadrat without any kind of individuals of the Diamantillarum. Then we have the second treatment with 3 cages without individuals of the Diamantillarum, and then 3 cages with 5 individuals in each cage. We found, especially in zone 5, highest diadema antillarum density with 24-25 per 10 meters square, and the lowest we found in the zone 7. But also, if you see in the zone 3 and 2, the density of diadema was very low too. In the case, if you compare the numbers of diademas in reef crest and reef slope, basically in reef crest we found highest numbers of diademas with 1,000, more than 1,000. But in the case of reef slope, the numbers of diadema was lower, with 255 individuals. In terms of cover, of the substrate cover of the cages, we found differences between August and September. So it seems that the effect of the edema was very effective. For example, if you see in the photographs, in the low area of the slide, you could see how Dictyota genus was abundant in the photograph of August 7, but in the case of September 6, all of the Dictyota was disappeared. Same situation you could see with cyanobacterias, where the cover decreased at the cage 3 in just 1 month. And in the photographs below in the slide, you could see a juvenile sea urchin of diadema that entered into the cage in this month. This was an unexpected result. So, in front of this scenario where we have different situations in different reefs of Cuba, what next? Which are our plans for the future? First of all, I'd like to emphasize that the almost 80%, 90%, 98% of our platform are coral reefs. But in the case of the research of coral reefs, we have gap of knowledge, important gap of knowledge. For example, in the eastern area of the country, same north and south, we almost don't know nothing about the health and the situation of the coral reefs. Other problem that we face, it is that we have, even when it seems that we have many research in our coral reefs, but these research are in different years, were conducted by different researchers with different level of expertise, and this provoked that the information that we have right now are or dispersed, or we have gap of knowledge, or were conducted with different methodologies. So it's different to compare or different to know exactly in which situation we have right now along all the country. Because of that, what we propose for the next year, in between July and August, 8 weeks more or less, it is have an expedition along entire of the island, in order to get as a baseline of the status of our coral reefs in the next year with the same group or the same team of researchers, and at the same time using the same methodology. This is one of our dreams for the future right now. So thank you very much by your attention. I'm sorry if I take longer.
Thank you very much, Dr. Gonzalez, for for the the work that for explaining and presenting the work that you and your group are doing all around Cuba. Our next speaker is Dr. Nestor Rey-Villiers. Dr. Rey-Villiers is a postdoctoral fellow at the Institute of Marine Sciences and Limnology of the National Autonomous University of Mexico in Puerto Morelos. And he's also a visiting professor at the National Polytechnic Institute of Mexico. He holds bachelor's and master's degrees from the University of Havana, and he actually did his PhD in Mexico at the National Polytechnic Institute. Dr. Rey-Villiers' research has been on the biology of Cuban octocorals. Octocorals they're commonly known as soft corals. And so he does research on octocorals and their responses to changes in water quality. And this includes the processes and biological traits that contribute to the resilience of octocoral communities and to human-caused and effects of human-caused pollution and climate change. So I'll turn it over to you, Dr. Rey-Villiers.
Thank you for your invitation. Well, hello everyone. My presentation is in English, but I will speak in Spanish. I think it will be better for you and you will understand me better, okay? Well, los bosques de octocorales actualmente están presentando señales de resiliencia en el ecosistema, los ecosistemas arrecifes de coral en lo que es la cuenca del Atlántico Oeste, específicamente en el Caribe. Vamos a ver un poco cuáles son los octocorales. Existen diferentes especies de octocorales en los arrecifes del Mar Caribe. Los más conocidos comúnmente pues, son los abanicos de mar, pero existen otra serie de especies de octocorales que tienen otras formas de ramificación y que también habitan los arrecifes de coral, como por ejemplo las plumas de mar, las varillas de mar y los látigos de mar. Todas estas especies de octocorales son organismos bentónicos, sésiles, organismos coloniales y tienen una amplia distribución. Para que tengamos una idea, podemos encontrar octocorales desde el Ártico hasta la Antártica y en un perfil batimétrico podemos encontrar octocorales en la zona intermareal hasta las zonas abisales. Es un grupo muy diverso, se han descrito aproximadamente 3.200 especies a nivel mundial y este grupo cada vez está prosperando con mayor abundancia en los arrecifes del Caribe. Podemos encontrar lo que se conoce como las planicies de Borgoña y un término más general, más global que se está empleando, que son el de bosques de animales marinos, que son todas aquellas comunidades animales que forman estructuras en 3 dimensiones, compuestas principalmente por organismos megabentónicos sésiles de larga vida que pueden alimentarse de materia particulada suspendida en la columna de agua, generando estructura y hábitat para muchos organismos en los arrecifes. Observen la densa canopia que se encuentra en esta comunidad de octocorales y este escenario cada vez lo encontramos más en los arrecifes del Caribe y Cuba no es la excepción de este escenario que estamos encontrando. Acá les muestro algunos datos de los cayos de la Florida. Observen cómo el triángulo es la cobertura de octocorales, es uno de los organismos, o sea, uno de los grupos bentónicos que a lo largo del tiempo ha ido incrementando en abundancia, a diferencia de los corales escaractinos que han ido disminuyendo lo que es la cobertura. Este escenario también lo encontramos en otros arrecifes del Caribe, por ejemplo, en 2 sitios de las Islas Vírgenes. Observen cómo los puntos azules representan la densidad, la abundancia de los octocorales y observen cómo en ambos sitios la tendencia a lo largo del tiempo ha sido a ir incrementando, a diferencia de los corales escleractíneos que ha ido disminuyendo pues, su cobertura. Estos son señales, son evidencias que muestran cómo este grupo está o puede estar teniendo cierta resiliencia a los estresores tanto locales como globales que tenemos hoy en día en los arrecifes del Caribe. En una gráfica ya a nivel más global, observen cómo desde el año 1968 prácticamente a la actualidad tenemos las mismas abundancias de octocoral, o sea, no se ha perdido abundancia de octocorales, y a lo largo de los diferentes sitios que les mostré de las Islas Vírgenes se ha mantenido también esta abundancia. Y pues Cuba no es la excepción de esta tendencia que les acabo de comentar, de este panorama general que está ocurriendo en la cuenca del Atlántico y específicamente en el Caribe. Aquí les muestro los principales arrecifes de Cuba y el doctor Alain estuvo platicándonos ya en la primera presentación. Quiero que observen cómo los principales arrecifes de Cuba con la mayor cobertura de coral se han encontrado en lo que es el sur de Cienfuegos, Bahía de Cochino y el Golfo de Cazones. Y en estos sitios, particularmente, observamos los menores valores de densidad de octocorales. O sea, hay determinados arrecifes de Cuba que todavía no han sido reemplazados por estas especies, lo cual es una buena noticia. Todavía tenemos arrecifes bastante bien conservados, pero hay otros arrecifes donde la cobertura de coral ha disminuido muchísimo, como por ejemplo los casos del archipiélago de los Colorados y Sabana Camagüey, y en estos arrecifes han sido reemplazados o la mayor abundancia, ha incrementado la abundancia de los octocorales, como podemos observar en la gráfica de aquí abajo, en lo que es la abundancia de octocorales en el archipiélago Sabana Camagüey y en los Colorados. No hay diferencias prácticamente con los sitios de Mayabeque, que fueron donde se observó la mayor abundancia de octocorales. De tal manera que son evidencias de que este grupo puede estar reemplazando, pueden ser las especies que comiencen a reemplazar muchos arrecifes de coral, ya no solo en Cuba, sino también en el Caribe, y un poco en cuanto al escenario de lo que puede ser el futuro de los arrecifes de coral, en caso de no revertir determinados estresores locales y globales que están ocurriendo en la actualidad, pues el escenario puede ser a que estas especies cada vez prosperen más en lo que conocimos en algún momento como los arrecifes formados principalmente por los corales constructores, ¿no? Los corales escleractíneos. Entonces, les voy a platicar un poco sobre los diferentes procesos biológicos y ecológicos que pueden contribuir con la resiliencia de los octocorales, como por ejemplo uno de ellos, hay varios, pero uno de ellos, en el cual me voy a enfocar, es la estrategia morfológica que tienen estos organismos y su rápido crecimiento vertical. Se fijan en el sustrato por la base y crecen rápidamente hacia la superficie con una morfología, con una estrategia morfológica ramificándose, no sobre el sustrato. Esto evita diferentes procesos que ocurren en el sedimento, y vamos a ver cómo en uno de los sitios, o mejor dicho, vamos a ver cómo en una de las localidades donde está cercana a diferentes cuencas fluviales que están contaminadas y cercana a la ciudad que está más densamente poblada en Cuba, que es La Habana. Vamos a ver cómo hay diferentes estrategias que están ocurriendo con dos especies para que no disminuya la abundancia de una de esas dos especies. Y observen cómo la densidad, la abundancia de los octocorales en La Habana no presentó diferencias con los sitios que tuvieron la mayor abundancia de octocorales. Bueno, en La Habana existe un gradiente, es un caso de estudio que les voy a platicar, y es que en La Habana existe un gradiente de contaminación orgánica principalmente. Observen cómo en el PCO, a lo largo del PCO1, describe prácticamente un 60% de la variación total de todos estos sitios. El color rojo son los sitios que están más eutrofizados, y el color verde son los sitios que están un poco más alejados de estas cuencas y tienen mejores condiciones. Este gradiente lo pudimos realizar a partir de diferentes variables hidroquímicas, microbiológicas, isótopos estables, diferentes variables físicas, y muestra un gradiente de contaminación en esta zona costera. Los sitios más contaminados son PAM, PU, bueno, son sitios que están cercanos a lo que son las descargas de la bahía de La Habana y los principales ríos de la ciudad, como el río Mendares, el río Cuba. Observen cómo una de las especies que les voy a presentar es Eunicia flexosa, la otra es Plexaura quequentali, pero observen cómo todos los indicadores morfométricos que medimos en esta especie se afectan con este gradiente de contaminación orgánica. En el eje de las X tenemos el eje del PC1 que describe ese gradiente de contaminación y observen cómo todos los indicadores morfométricos en esta especie disminuyen en función de ese gradiente de contaminación, siendo una especie sensible a este factor. Sin embargo, existen otras especies que son tolerantes, como por ejemplo Plexaura quequentali. Quiero que observen cómo ninguno de los indicadores morfométricos en esta especie tuvo una relación con el gradiente de contaminación orgánica, lo cual es una evidencia de que la morfología de esta especie no se afectó, lo cual puede tener efectos importantes en cuanto a la abundancia de esta especie bajo esas condiciones ambientales. A lo largo del tiempo, quiero que observen cómo en Eunicia flexosa existe un efecto crónico de lo que es la calidad del agua en la morfometría, en la altura de Eunicia flexosa. Observen cómo en los sitios más contaminados obtuvimos el mayor porcentaje de colonias en los menores intervalos de talla en los tres sitios más contaminados, a diferencia de los sitios alejados, donde hay una distribución más completa de lo que es la altura de esta especie. A lo largo del tiempo fueron desde el 2008 al 2016. Sin embargo, en Plexaura quequentali no observamos eso. Observen cómo en la desembocadura del río Cuba, que es este sitio de acá, la distribución por talla no tiene diferencias con respecto a los dos sitios que están más alejados de lo que es la bahía de La Habana y de lo que es el desarrollo urbano de la principal ciudad más densamente poblada de Cuba, lo cual son evidencias de que esta especie a lo largo del tiempo su altura tampoco se está afectando. Y esto tiene implicaciones ecológicas importantes en cuanto a la abundancia. Se ven cómo para Eunicia flexosa la abundancia de esta especie disminuye en función de la altura. Lo que es lo mismo es que a medida que está disminuyendo la altura de la población, de las poblaciones de Eunicia flexosa, se está viendo afectada la abundancia de esta especie, lo cual no pasa para Plexaura quequentali. Y por supuesto esto nos pone en un escenario de que pueden haber especies que son sensibles como Eunicia flexosa, y hay otras especies que desde el punto de vista morfométrico y abundancia van a ser más tolerantes a lo que es el enriquecimiento de nutrientes. Por lo tanto, bajo un escenario de estresores locales como es los impactos antropogénicos relacionados con la contaminación, principalmente en este caso orgánica, podemos esperar que en un futuro los arrecifes de coral puedan estar siendo reemplazados por especies tolerantes de ortocorales, como por ejemplo el caso de Plexaura quequentali. Y así un poco lo estamos observando en lo que son los arrecifes de La Habana. Quiero que observen cómo en la desembocadura de la bahía de La Habana y del río Almendares, la abundancia de Eunicia flexosa es significativamente inferior a la abundancia de esta especie en sitios más alejados. A diferencia de Plexaura quequentali, en la desembocadura de la bahía de La Habana, por ejemplo, no hay diferencia en cuanto a su abundancia con respecto a otros sitios más alejados, como por ejemplo SA. Entonces, son ejemplos de que esta especie, como una especie tolerante, Plexaura quequentali, puede reemplazar determinadas especies de corales extractíneos bajo condiciones ambientales de estrés por enriquecimiento de nutrientes. Por lo tanto, podemos esperar que en un escenario de enriquecimiento de nutrientes como el que estamos teniendo en muchos arrecifes del Caribe, muchos arrecifes de coral puedan verse reemplazados por octocorales y octocorales tolerantes a estos estresores. Entonces quiero terminar con un mensaje. Uno es claro de que hay especies octocorales que a pesar de ver un escenario a nivel de cuenca del Atlántico Oeste y específicamente en el Caribe de un incremento en la abundancia de estos organismos, existen especies dentro de este grupo que son más sensibles a determinados factores, como por ejemplo a la eutrofización, pero hay otras especies que son más tolerantes desde el punto de vista morfométrico y de abundancia, como es el caso de Plexaura quequentali, y puede ser la estrategia morfológica que tienen estos organismos, puede ser una de las características biológicas que contribuye a explicar su mayor abundancia bajo esas condiciones ambientales. Quiero cerrar este mensaje con dos imágenes. Una es en Boca de Caldera, es un arrecife que está aproximadamente a más como 40 kilómetros de lo que es la desembocadura de la bahía de La Habana, cómo está constituido principalmente por abanicos de mar, diferentes especies de varillas de mar, especies de corales blandos, de octocorales, pero no solo está ocurriendo en arrecifes que están cercanos a zonas urbanas. Uno de los arrecifes más protegidos que tenemos en Cuba, como el caso del Jardín de la Reina, en muchos sitios hay una abundancia de octocorales bien elevada, como por ejemplo, vean esta imagen. Entonces, agradecerle por la invitación al Instituto Cubano de Investigaciones a la FIU y a todas las instituciones con las que estamos colaborando. Muchas gracias a todos.
Thank you, Dr. Revillier. It's true. We often don't consider the important role that that octocorals, soft corals, play in coral reef ecosystems, and I think that your research really spotlights that. Our final speaker this afternoon will be Dr. Susana Pereira Valderrama. Dr. Pereira Valderrama is a marine monitoring specialist with Mexico's National Commission for the Knowledge and Use of Biodiversity, which is also known as CONABIO as well. That's probably most common. People know it that way. And she's also an assistant professor at the Autonomous University of Baja California Sur. She holds bachelor's and master's degrees from the University of Havana, and her PhD in Mexico from the Colegio de la Frontera Sur, which is also known as ECOSUR. That's the way it's usually known. She previously worked for Cuba's National Center for Protected Areas and has also led several projects related to marine protected areas in Cuba, including monitoring and research on marine ecosystems and endangered species in Cuba and also Mexico. And she's currently working on a monitoring program for marine protected areas in the Mexican Caribbean. So Dr. Pereira Valderrama, over to you.
Thank you, Jean, for the presentation. And thank you to the Cuban Research Institute for the invitation to participate in this panel. As Jean said, I have been working at the National Commission for the Knowledge and Use of Biodiversity for almost 6 years at the sub-coordination of marine monitoring. But before that, I worked for more than 12 years at the National Center of Protected Areas in Cuba. And because of that, I am really happy to share with you today some of the information related to the conservation of coral reefs in the Cuban marine protected areas. All this information is included in chapter 22 of the book Coral Reefs of Cuba, which will be published soon. And as you can see, I wrote this chapter in collaboration with several colleagues from the National System of Protected Areas of Cuba. Well, like in most of the Caribbean islands, the economy of Cuba is highly dependent on the proper functioning of the coral reefs. However, as my colleagues stated before, Caribbean coral reefs are among the most threatened in the world due to several natural and anthropic stresses acting in synergy, and Cuban coral reefs are not an exception to this. In Cuba, the importance of reef conservation is widely recognized by the Cuban government, and there is a strong political will to ensure that these ecosystems continue to provide ecosystem services to the Cuban society. However, coral reef management constitutes a big challenge in the current days, taking into account that the driving impacts of degradation of coral reefs are operating not only at a local scale, but also at regional and global scales. And as in other parts of the Caribbean, Cuban coral reefs are affected by local threats like coastal and marine pollution, overfishing, invasive species, and coastal development. But the entire region is also affected by global and regional threats like sea temperature change, ocean acidification, and hurricanes. So, due to the importance of coral reefs and the impacts and threats that affect them, several management strategies have been implemented worldwide, including the creation of marine protected areas. In the Caribbean region and in Cuba specifically, MPAs have been one of the most used coral reef management strategies. But although MPAs are likely not very effective in combating the impacts of regional or global stressors, they can contribute to mitigating local impacts such as overfishing, marine pollution, or massive tourism, increasing the resilience of reef to deal with the impacts of global stressors such as climate change. So to protect Cuban coral reefs, the government has implemented strong marine policies and legislation in the framework of the National System of Protected Areas. To date, this system is integrated by 105 MPAs proposed, of which 79 have management authorities. And this means staff and allocated budget, and 64 of these 79 have already been legally approved by the Executive Committee of the Council of Ministers. As we're going to see next, the reason for the creation of many of the Cuban MPAs has been the conservation of coral reefs. So currently in Cuba, 26.5% of its insular shelf is protected under some category of managed or legally approved MPA. So with this scenario, Cuba is in a good position to address the proposals of the Convention on Biological Diversity in the post-2020 framework to conserve the 30% of its marine territory. In Cuba, the National Center of Protected Areas, also known as CENAP, is the governing center for planning and management of the National System of Protected Areas. CENAP identifies and proposes the areas to be included in the system and the management categories, but CENAP is not in charge of the management of MPAs. So other agencies are in charge of the management and enforcement of MPAs. The agency managing more MPAs in Cuba is the National Enterprise for the Protection of Flora and Fauna of the Ministry of Agriculture, but there are also other centers of the Ministry of Science, Technology and Environment, the Ministry of Food Industry, and the Ministry of Agriculture involved in the management of MPAs. So, as I said before, among the main criteria to establish MPAs in Cuba has been the existence of diverse reef ecosystems, and because of that, of the 105 MPAs proposed in the Cuban system, 54 have reefs within their limits. Of these 54, 39 have legal approval and 7 are in the process of legal approval by the Executive Committee of the Council of Ministers of Cuba. So the system conserves more than 104,000 hectares, which represents 35 of the Cuban coral reefs. And this is an important percentage in comparison with the estimated 27% of the protected coral reefs of the world. So the MPAs with the highest coverage of coral reefs are First, the Banco de Buena Esperanza Managuano, outstanding natural element with almost 20,000 hectares of coral reefs. In this area, were described in 1980 by Slatarsky and Martinez Talela, the mud bottom reef or gelatinous reefs. The second area is the world famous Jardines de la Reina National Park. The third is Cayo Campos, Cayo Rosario in the Los Canarreos Archipelago, Los Caimanes National Park, and Ciénaga de Zapata National Park. This area is also a Ramsar site, recognized as one of the largest and best preserved wetlands in the Caribbean. All these MPAs have legal approval except for Banco de Buena Esperanza, which is in the process of legal approval by the Executive Committee of the Council of Ministers. So for the conservation of coral reefs in Cuba, the national system has had the support of several national and international institutions and organizations. It's a long list, which have contributed directly or indirectly over the years. But and such support have been mainly through the execution of national and international projects. And among the main international agencies that have supported Cuba in the conservation of coral reefs, I would like to highlight the Global Environmental Facility through projects like Savannah Camagüey, like the Southern Cuba Archipelagos, and the project Ecovalor, which is currently being implemented. And these projects have been implemented with the support of the United Nations Development Program. And also the United Nations Environment Program has supported the conservation of coral reefs in Cuba. Cuba is a contracting party of the Cartagena Convention and the Specially Protected Areas and Wildlife Protocol, also known as the SPO Protocol. And the support has come mainly through projects directed to the exchange of experiences, capacity building, and training. Also, WWF has also contributed to the creation with a work starting 3 decades ago to the creation of the main marine protected areas like Ciénaga de Zapata, Jardines de la Reina, Alejandro de Humboldt, as well as several MPAs in Los Canarreos Archipelago. And also individual MPAs have received the support of several organizations. I would like to highlight the support of the Nature Conservancy, the Ocean Foundation, Environmental Defense, Ocean Doctor, among so many others. And finally, I would like to highlight the Memorandum of Understanding celebrated in 2015 between the National Center of Protected Areas and the National Oceanic and Coastal Administration, and the to establish sister sanctuaries relationships. The first research and monitoring efforts conducted at coral reefs that are currently in MPAs were accomplished using the Atlantic and Gulf Rapid Reef Assessment, also known as AGRA. And then the first coral reef monitoring effort promoting the national system of protected areas began after the legal approval of the first MPAs in the early 2000s through the application of the reef check methodology. And then a more formal coral reef monitoring program in Cuban MPAs began in 2010 within the framework of the GET project, Cuba's Southern Archipelagos. For this, Cuban scientists and managers of MPAs develop protocols for coral reef bentos and fishes. And also to monitor coral bleaching in NPAs, the National Center of Protected Areas has traditionally relied on the volunteer coral bleaching monitoring program promoted by Dr. Pedro Colado. In relation to coral reef restoration efforts, since 2005, these have been implemented in several NPAs in Cuba. These initiatives began with the support of the Nature Conservancy, which held a training workshop on asexual restoration techniques, and then coral nurseries of different structures have been installed in several NPAs, in Guanacavives, Cayos and San Felipe National Park, and Laguna de Maya Fauna Refuge. And more recently, restoration strategies through sexual reproduction have been also promoted. And these initiatives have been executed by the National Aquarium of Cuba, the Center for Marine Research, the National Center of Protected Areas, with the support of national and international projects like the GEF project de Covalor, the support of the Nature Conservancy, the Ocean Foundation, the Florida Aquarium, and others. And well, regarding to the main uses, impacts, and challenges in Cuban coral reefs and NPAs, well, as you know, tourism is one of the main sectors of the Cuban economy. And in NPAs, even though diving and snorkeling are among the main tourist activities, fortunately, the existence of tourist centers within NPAs is limited, is still limited. And according to the monitoring analysis, the impact on the reef is not excessive. Several types of fishing occur in Cuban NPAs. The National Center of Protected Areas maintains a collaborative relationship with the fishing sector for decision making, but there are still fishing associated impacts, mainly related to illegal fishing activities. So conflicts between conservation objectives and the users of the resources are common. And to avoid these conflicts, functional marine zoning is implemented and managed in NPAs. However, the limited resources, the poor enforcement, and the turnover of personnel undermine sometimes the proper implementation of the zoning. So finally, as the main strategies that to guarantee the conservation of coral reefs in Cuba, well, we suggested to maintain and increase national and international collaboration in the framework of the National System of Protected Areas, to continue increasing capacity building and public awareness through continuous work with stakeholders and local people, and to continue promoting the assessment and implementation of nature-based solutions. Thank you very much.
Thank you very much, Dr. Pereira Valderrama, for this overview of the extensive system of Cuban marine protected areas. I want to remind the audience that you can enter questions in the Q&A function, and actually, I'd like to start with a question from the Q&A from Leonel Morejon Almagro, who asks, and this is for the panelists who have knowledge, I would imagine, especially Dr. Pereira Valderrama, but also for others too, if you know, what is the role of independent ecological groups, you know, NGOs, non-government organizations, local groups, etc., in Cuba, in coral reef management and conservation within Cuba? You can all turn on your cameras now, by the way, and turn on your microphones. So did you got my question, or? from Leonel Morejón Almagro about the NGOs, role of NGOs?
Yes, NGOs and several stakeholders are included in the National Board of Protected Areas, where the main discussions related to the protected areas management are dealt. So I think this is the proper figure to hear the voice of the NGOs.
Anyone else want to chime in what you know about that? And
Yeah, but let me step in pretty quick. The role of NGOs and in marine protected areas in Cuba is mostly related to their help funding projects through which the marine protected systems actually do perform their monitoring systems. Is rather than managing and proposing ideas to manage MPAs, it is funding and helping to conduct all these monitoring efforts across the island. Is that right, Susan?
Yes, it is. Sorry.
Yeah.
all right. Another question from the audience comes from a professor in my own department, Ligia Collado Vides. And this is a question for Dr. Revillier. You can please answer in English or Spanish. It's okay, no problem. Ligia is asking about the relationship between octocoral abundance and or any other metric related to octocorals, the relationship with sponges, because she noticed one graph that you had information about sponges in the graph, and whether that depends on the species of sponges that are present. So the effect of sponges on octocorals.
Y esa es una pregunta muy interesante. Primero es que el gráfico que mostré es un gráfico del comportamiento, o sea, de la abundancia de diferentes grupos bentónicos a lo largo del tiempo. Dentro de ellos están, pues, las esponjas, pero las esponjas como comunidades, no especifica las especies. Entonces, una de las ventajas que precisamente tienen las gorgonias, a diferencia de muchas especies de esponjas que sí crecen sobre el sustrato, es que los procesos de competencia entre todos estos grupos, esponjas, gorgonias, corales, esferactinios, algas, son bien fuertes, todos estos procesos de competencia. Pero en el caso de los octocorales, la ventaja que tienen es que al crecer hacia la superficie, evitan un poco todos los procesos de competencia, requieren menos energía para ocupar un lugar en el espacio, a diferencia de otros grupos bentónicos que sí tienen que ramificar, que crecer sobre el sustrato. Entonces, es un poco por ahí mi respuesta.
Okay, thank you very much. For the next question, I'm going to go back to the multiple mentions of the role of the sea urchin diadema. And Alain, you mentioned at the beginning of your presentation, you know, that there had been big changes in abundance in diadema. And some in the audience may not be familiar with what's happened and over a period of a long period of decades. So what's the story about the diadema? And anyone else, please, after, you know, also add anything you would like as well. But in the first instance, to Alain.
Yeah, that's an excellent question. And Jim, I don't know if you have noticed, but I've been also answering questions in the QA. So I wrote multiple answers as well. And related with this, back in 1983, 84, there was a massive die-off of diadema across the entire Caribbean. This is not actually unique to Cuba. And there are a couple of hypotheses. The most accepted one is a virus. It's a virus that was spread. We don't know. I don't know. I don't have any information on where actually it started, but it was supposed to be something that spread out through entire Caribbean pretty quick, and in only 2 years, their densities actually drop by 90%. That was the first one, by the way, that was supposed that seems to be a virus. The second one, this is the most recent one. I don't know if the audience knows about this. Was last year, the last 2 years actually, and this we know that is in the USVI, in US Virgin Islands, and apparently from there has been spread through different areas. We hopefully have not seen that here in Cuba yet, but everybody is kind of in the lookout for it. We don't know the agents of this disease. Apparently it's the virus, and that is based on how fast the spread can actually take place.
Thank you. Anybody else? I have another question. Okay, I have another question. This one is from Ricardo Perez, and his question is, in the first instance, for Dr. Duran, but anyone else as well, I think, who might know, who might have some views on this. It's been mentioned that tourism development is going to be a challenge for Cuban coral reefs, and Mr. Perez is wondering if you could elaborate on exactly what those challenges are to the health and preservation of Cuban coral reefs.
Susan, Nestor, do you want me to jump on this one?
Yes, as I said before, fortunately, there are just a few tourist centers inside the boundaries of the marine protected areas. So until now, it's not a big challenge. And I also would like to address the question from Isabel James about the agencies from separate ministries handling MPAs. Well, in this case, the National Center of Protected Areas establishes the guidelines for the planning and management of MPAs, and the other agencies from other ministries are in charge of implementing these guidelines through the management of MPAs. So thus preventing the National Center of Protected Areas from being judge and party at the same time.
Thank you. And also, yes, of course, in your work, Dr. Pereira, you would have a lot of knowledge of the effects of the threats that are, or the challenges posed by tourism to coral reefs. To step back one question. What do you think?
Can I add something pretty quick?
Sure.
What I was referring as the challenges of the potential tourist development is that if the system in Cuba change and there is a rather fast development of tourism and there are more tourists coming from different places, then the potential of those ecotourism that may not be well managed is still in place. And I remember back in the days, I'm talking about potential, man, this had to be 2008, 2009, that Dr. Pedro Colado was actually working with several dive centers and collecting data on what is the carrying capacity of different reefs. So how many scuba divers, for instance, you could put on a reef without producing further harm. Right, so what would be the maximum number of divers in a year for that particular reef that could, you could get a profit from it. Everybody needs to support, but needs that support, but without harming those systems. And I don't know, Susanita, who actually kept working on this. I remember Pedro. Man, he mentioned some numbers, and I don't have them. It was like 4,000 divers per year per site, something like that. But it actually changed a lot depending upon what type we were talking about. So that is a kind of challenge that I am thinking about, Gene. That if we don't have the capacity right now to research, and there are some reefs that we don't know well yet. So if there is a development of tourism, that could lead to potential negative impact on coral reef because we don't know these metrics that I was talking about, for instance, carrying capacity.
Thank you. There's a question here. I'm just going to do two more. A question here from Isabel James, who's referring to the memorandum of understanding for sister sanctuary, so marine protected areas, sister sanctuary relationships between the National Oceanic and Atmospheric Administration of the U.S. and the system of marine protected areas in Cuba. Is this currently active? And will there be any? Is there going to be any progress in under the current administrations?
Yes, this memorandum of understanding was signed during the Obama administration. So after that, I think that it stopped. So I'm not sure if I can address this question right now. Sorry.
And okay. Does anyone else know anything about it? Not, if not, I'll ask. I have one final question, and that is, well, there's been mentioned today in the presentations about coral reef restoration efforts, and we have that going on right here in Florida too. Here and around Miami and the Florida Keys, etc. But do you think that in your view, is coral restoration viable? Is that really going to work, or is it just, can it only be done in a few little areas?
So far, it has been implemented in marine protected areas in 3 or 4, and is in the beginning of the strategies, and also in the north coast of Havana. But so far, the strategies have been effective, but I think we need more years to assess the effects.
Anyone else have a view on that?
Yes, Jim, are you referring to coral restoration in Cuba, or are you referring
both,
to
both?
Right. Well, I would say that is really variable depending upon where the sites, where are the abiotic conditions, where are the factors driving what actually drove, right, the coral community, let's say in the case of the Florida, to decline so fast, especially after 2014 with the stony coral disease. It really is an alternative. It has been proved to be effective in more than one place, not just in the Caribbean, but also in the Pacific. It could work pretty well in Cuba, in my opinion. But again, coral restoration takes a lot of resources, right? Marine biology per se is a very expensive field. And coral restoration, different from what happens in Florida, where you have multiple volunteers paying to actually go out there and do the outplanting of the corals. In Cuba, it's a little bit different, and therefore the economic limitations is what might be limiting this effort. But I think it's totally viable. That will be the final answer.
That's an optimistic note on which to end our panel. And I would like to extend thanks to our panelists, to the Cuban Research Institute for this rather different kind of Cuban studies that we've been exposed to today. So thank you very much, and hope to see you again at another Cuban Research Institute event.
Thank you.
Bye.
Thank you.
Thank you.